Service discovery is such a key component to building microservice applications. And in this video, we're going to have some folks on from the Steeltoe team who are going to show us how we can add service discovery to our .NET APIs. Hi everyone, welcome to another episode of the On.NET Show. And in the next series of videos, we're going to take a look at the Steeltoe framework, which is going to show us how we can build microservices in our .NET applications. Now, before we start getting into it, I want to introduce some gentlemen from the team. I'm going to have David and Tim talk to us. So why don't you two introduce yourselves really quickly so we can know a little bit about who you are and what exactly do you do?
Sure. Thanks, Cecil. I'm David Dieruf, longtime .NET advocate. I work on the VMware team in Tanzu product. Anything .NET pretty much falls on my plate over there. I eat, sleep, and breathe it.
Hi, I'm Tim Hess. I'm an engineer on the Steeltoe team. I've been working on this project for about 3 years, been in the .NET space for well over 10 years.
All right, so why don't we just go ahead and get into it, right? Tell me a little bit about what exactly is Steeltoe, why should I care about it? You know, what kinds of problems exactly does it solve for me?
Thanks, Cecil. So let's talk about Steeltoe and how developers build .NET microservices. So the Steeltoe framework was created in 2015. It was donated to the .NET Foundation a few years after. It's an open source project that enables .NET developers to bring resilient best practice microservices to the cloud. Another way to put it is it makes your .NET coding quicker, easier, safer, speed, simplicity, productivity, all the good things that you would normally hear about things. This is the key. Steeltoe is not replacing .NET at all, right? This is the .NET runtime, so much goodness in there. What it does, though, is .NET has to cover a lot of different areas as a runtime, right? Console apps, microservices, web API, Blazor stuff, all of that. Specifically in the microservice world, ASP.NET, Steeltoe helps you add some cloud opinion in that, right? We know the environment we're going to be running in here. We know that we're running web APIs. So we can deliver some ready-to-run patterns in a pretty darn stable, good way. As far as service discovery goes, right, when we're talking about those microservices, we're talking about delivering those baked-in patterns. So first of all, a service registry. Think of it as a phone book for your microservice. Each service registers itself and tells the registry things like, here I am, here are the different hosts that I'm going to be on, the ports that I'm going to run on, things like that, right? Like a phone book. And then you also have clients who come in and ask the registry, look, I have this name of this service. Can you tell me its address, its URI, and its port number and things like that? We can also pack in some other metadata and things like that. But the basics here of service discovery are the URI and the port for it. We can also do some other fun stuff with it. The architecture, basically in a microservice architecture, your instances are always on the move, right? Your application is relying on all these services to be available, though. So you got to create some sort of mix there between the two, some sort of solution. And the service registry removes the complication of, I don't actually have to remember where all these different services instances, maybe different data centers is running. All I need to remember is the name of the app, and I can be told or possibly load balance for all these different instances and get to one.
So David, a lot of what you've said about service discovery reminds me a lot about DNS, right? Particularly that phone book analogy, right? Because we think about DNS as the phone book of the internet, right? Is service discovery very similar to that? Is it built on top of DNS, or is it something completely different?
No, it actually, that's an interesting analogy because in some respects it is. To tell you the truth, the thought that pops into my head, though, is DNS is a very long-living thing and really doesn't change that often, right? The assignment of a name to an address really doesn't change that often. In the microservice world, it's constant. And so a service registry is similar in respect to the phone book and DNS and that sort of thing, but different. because it is very resilient to change. And it gives you specific features for, look, I know this thing probably isn't going to be in the same place tomorrow. So give me ways to overcome that and adapt.
Okay, well, that makes sense. And I think also from a microservice world perspective, one of the reasons that we do want to have service discovery is because, like you said, the services are a little bit dynamic, right? Like I can have one or many of one particular type of service, and then they come up and they create and destroy themselves very quickly. So I need to know, like, where are they? Are they healthy? How can I reach them? What is their address? And these types of things, right? And that's a non-trivial thing for us to do. And that's where these registries come in to kind of help us solve some of those problems.
And building on top of that, once you're using a service registry, your application is able to know where all these instances are and use its own load balancing pattern. So we provide some patterns out of the box, like a random load balancer and round robin, but you can write your own.
Cool. That sounds pretty good. I know you guys have a demo. Why don't we move forward and take a look and see what it actually feels like to create one of these?
So like any good demo, we are going to start completely from scratch with a brand new project. And we're going to do all of this the fun way, though not the most reliable way. Here we go. We're going to make a weather API as our background source. The plan for this is we'll make a weather API in the background, and we'll have a weather website in the front. And we will call this backend project our weather API. And I'm going to change the solution name because I hate having the same name for the project and the solution. And while this is spinning up our web API project, I am going to go ahead and use Docker to spin up a Eureka server, which is what we're going to use as our service registry. And I'm going to say Docker run, and I want to remove it when I'm done. And I'm going to do some port forwarding here so that I can rely on the defaults. Eureka listens on port 8761 by default. And I'm going to pull down a Steeltoe provided image that's great for doing local development, but probably not intended for use in production. And we'll just go ahead and start that Eureka server in the background.
Okay. And so, like you said before, Eureka is just one of a few different options that are available for registries. Yes. And its sole purpose is to be that phone book, right? Like, these are the services I have, and this is where I can find them.
Absolutely. So Eureka is powering up in the background. We have our web API project here. I'm going to switch the debugger on this to use the project directly because I don't want IIS Express getting in our way at all. I'm going to go ahead and add our other project right off the bat. And it's going to be another ASP.NET Core application. And this will be our weather website. And it is going to be an MVC application. And now we have two applications. It's exciting. I'm going to go ahead and plug our NuGet packages in right away so that is out of our way. And there are three of them that I'm going to be adding today. I'm going to start with a Steeltoe common hosting package, which doesn't do a whole lot for us, but it does make it easier to specify the port that an application is listening on. This is relevant for local instances. It makes it easy to switch the port that it's listening on so that if you have two brand new templated applications, you're not trying to fire them both up on port 5000.
Yeah, that sounds very helpful.
So then I'm going to add the Discovery Client Core package, which currently knows about all of the Discovery implementations that we work with. And I'm going to add that to both the API and the website project so that they both will be able to get wired up and talk to the Discovery backend server. And the third package I'm going to add is just to help with the deserialization of the weather API responses when I make calls from the front end. So that's the system.net.http.json package. Get that guy in there. And then this should be all that we have to do with NuGet packages for today.
Okay.
I'm going to make that same startup change on the website so that we get nice little console windows for both of them.
Cool.
I'm going to go into the program CS file in the weather API. Go ahead and
could you make that font size just a little bit bigger for us?
Absolutely.
It's a little small.
Is that good?
Yep, that looks good. Thank you.
All right. That common hosting package includes this extension for use cloud hosting. I'm going to run the weather API on port 80 because everybody loves web services running on port 80. And that's it for setting up that port binding. And what this does when you deploy it to environment or to cloud platforms that provide a custom port for any given instance is it will read that environment variable and it will listen on that port instead of this port. So this parameter is only used when it's running locally.
Oh, okay. Got it.
The next step, of course, is to configure the services that we want to be providing in our dependency injection. So we want to go ahead and add our discovery client here. And we'll give it our configuration. And then we want to make sure that that is activated when the app starts up, so that it begins registering, in this case with the Eureka server. And I'm going to turn off this HTTPS redirection for right now, just because that can sometimes cause issues and we don't need any surprises.
Okay, so far what you've done, so you've installed some NuGet packages. You've, inside of the configure services, you've added, you've injected the discovery client, and then you also added it to the pipeline inside of configure services. Mm-hmm. So I'm guessing, I'm assuming now what this will do is, based on whatever configuration we have, it'll register this API with the registry. I feel like I'm saying register a whole bunch, but like yeah. it'll add an entry to the registry to be like, this is where I am and this is where you could find me.
Absolutely, and so what this does is it doesn't actually do anything with the HTTP request pipeline, but it provides a nice convenient place for us to start a background thread.
Got it.
So periodically it'll report its health to the service registry and make sure that the registry information is up to date. So the last thing that we have to do with the weather API is provide some configuration so that Steeltoe knows which service registry we want to use. And because I have a terrible memory, I can't remember all of our configuration keys. So I like to plug in a little JSON schema here to get some IntelliSense and help me remember what the configs are. Oh, okay. So we have the Steeltoe config at steeltoe.io/schema/latest/schema.json. And that should make it nice and easy to plug in our Eureka configuration. And I know that in this case, we need to tell Eureka what the service is called. Okay. And so we configure our Eureka instance app name as the weather API. And that's it. The rest of the defaults should work just fine for this setting. So should be able to go ahead and close out everything in the weather API. And then just to make communications easier between the two services, I'm going to go ahead and copy this weather forecast class from one to the other. Ideally, in a real-world situation, we'd put that somewhere else and use a NuGet feed to keep them up to sync, or some other pattern there. But this will work for us today. So I'm going to repeat that same set of changes. I'm going to go into the program CS file in the website API. We will use our cloud hosting here, and this time we'll give it port 81, thereby avoiding collision. We'll go into our startup file. We'll add our discovery services again. And we will make sure that that client is activated.
So essentially, you're doing the same thing in both places, right? So you're allowing the website to be discoverable, and you're also allowing the API to be discoverable.
Yep, and there's some configurations later so that we can, if we want to, turn off the registration of the web front end, because theoretically nothing's going to be looking for it unless we have something else in play, like a Spring Cloud Gateway. But we're not dealing with that today. Again, I'm going to turn off this HTTPS stuff just to avoid any conflicts there.
Okay.
And then now we've got these services hooked up and fired, but there's going to be some HTTP communications for us, and I like to use the HTTP client factory, and I can configure that in here. So I'll go ahead and do that as long as I'm already in this file. And that way the HTTP client will be configured for us later when we need it. So we'll add a client. We're going to name it weather. And we know that all of our weather interactions are going to have the same base address. So we'll go ahead and configure that right here as well. I think. All right, so this is going to say, this is where we put the service name. So we registered our weather API as weather API, and then we know that all of our requests are going to go to a service named weather API, and something in the background is going to resolve what that actually means for us down the line.
Right.
But in order to actually activate the discovery components on this particular HTTP client, we need to add our service discovery right here. And now that HTTP client has a base address of weather API across the board, and it will always use service discovery to resolve it.
Oh, that's cool. Okay.
Okay, so.
And I'm guessing what that was doing too was it was adding an HTTP handler, I'm guessing, in the background to wire up into, so that like when that client makes that request, the handler would fork out and talk to Eureka or whoever we're using for our registry to get that information.
Absolutely.
Got it.
All right, so app settings again. You know what, I'm actually just going to copy this one out from the other one so I don't have to retype the whole thing. And in this case, we don't need to set the app name. I'm just going to go ahead and tell it not to actually register with Eureka, and we'll use the rest of the defaults. So we'll configure our Eureka client. Okay.
Okay.
That's it for the app settings. So now we have all of those pieces. We still need to wire up something to actually make that call out to the weather API. I'm just going to go ahead and plug that into the home controller here. We'll inject our HTTP client factory. Keep a copy of it around. And then inside of our index, we will go ahead and we'll retrieve that, that client that we configured, which we named weather. All right, so we'll go ahead and continue getting our weather forecast here, which comes across from the API as a list because it's actually the forecast for, I believe, 5 days.
So I think what could be really great about this is just with that little bit of configuration you added, and it really wasn't a lot, this HTTP client factory now is going to be able to go out and dial into the phone book, right? And it's going to be like, hey, could you give me something that knows about weather, right? Like give me some information about it. And then now you can start making requests. And you're not going to have to hard code URLs and some of this other types of things that we usually have to do.
Right, yeah, and our code is extremely simple and basic and clean. So that's pretty fantastic all the way around. All right, so now we've got.
Honestly, that Cecil is one of the benefits really with Steeltoe that we found with a lot of developers is they take a point of view of simple. Few lines of code, you get a heck of a lot of bang for those few lines of code, and this is a great example.
Right. So now we've gotten that data. I'm guessing we have to show it on the page somehow.
Yes.
Inside of this Razor view.
So our model is going to be a list of weather forecasts. And then we'll just update our welcome message.
Nice. Welcome to the best weather website. I love it.
I'm going to tell them what we're going to show them here. So here's forecast. And we'll put it in a table because everybody loves tables. Give it a little bit of style. And then we're going to need some headers so we know what we're looking at. And for each forecast item, it's going to be a day of the week here. And I believe it comes with a summary as well. And we'll go ahead and we'll display the temperature. So for each weather thing in the model, and another row, pull the date, get the day of the week. Just do your simple data dump onto the page. Okay, anybody want to take bets on whether that works?
Let's see, I've got a dot, boom, boom, boom. Yeah, that looks good to me. So again, we're going to call into the registry. This time we just happen to be using Eureka. We're going to instantiate that HTTP client factory we did inside of the controller. We got some weather items back, and now we're doing what we usually do in .NET, right? Like we're for eaching over a model, which is nothing different or out of the ordinary from what we usually do. So the code looks, again, very familiar, right? Even though we're doing something a little bit different in terms of like using service discovery to get that information.
All right, I am going to fire up the Eureka dashboard just so we can take a look and see that there's nothing there right now.
Okay.
So that dashboard comes out of the box with that Docker image. I'm running at port 8761. And this is where the instances would show up, and there's nothing registered right now.
Okay.
So we'll go ahead and start the weather API. And this is where I was supposed to check a box or uncheck a box when I started from the template.
Oh,
and I missed that step. Yeah. So hopefully there's nothing remaining that gets in our way here. Looks like it started up just fine. And it registered.
Ah, awesome. So there's the API.
So by default, it used my machine name and then the name that we provided, and then it knew the port. So we'll go ahead and turn the website on, and we'll see if it knows how to connect all the dots.
All right, and then I remember you said you did not set the website to register itself. But even though the configuration that's there will still allow it to be able to use the registry, even though it itself is not a registered service.
Correct.
Okay.
It's just one less operation that the website application needs to perform over time. So, this is up and running now. It hasn't registered, and we should be able to hit localhost 81 and get some weather.
And there's the weather. Boom. So it's working. It's great.
Yeah, I don't know what happened to the temperature, but
that's fine.
Yeah. So yeah, you can see right here that the original request started as weather API, and then it was resolved to the host name.
There's your DNS, right? The analogy back to a phone book and DNS inside. It always comes down to that.
Yeah, I mean, in this particular case, it does actually resolve via DNS as well. So it does the registry, and then it does DNS, which makes sense in some scenarios where you've got distributed scenarios, and a DNS lookup still makes sense. Typically, what you would do is have this prefer the IP address and talk to the IP address instead.
So that was a really interesting demo about how we could use service discovery and Eureka to kind of get information back from some distributed services that we have running in our architecture. Why don't we head back over to the slides really quickly and dive into a little bit more information about some of the things that we could do and some of the benefits of using service discovery.
All right, so why would you want to use Steeltoe service discovery? Well, we provide some abstractions on top of the base layer. We have our own Eureka client, but we also have an overlay so that you can, through configuration, just swap in HashiCorp console, or you could use a native Kubernetes option. We do have some other really basic options. There is one that I wrote for unit tests, actually, but you can use your configuration to actually, through your iConfiguration infrastructure, write out your services if you've got an extremely simple use case where maybe Eureka's overkill and you've got something where you still want to use the pattern, but it's a bit more static. This tooling also has logging and health checks built in. So when you're using something like a Eureka, we will automatically inject health contributors. So you can have instant reporting of how the health is between your application and the service registry as well. Again, the registering and discovering of services is made super simple with just a few lines of code. So the registries that are currently supported, Eureka is the one that we've had around the longest. So it's got the most functionality. It's the most tried and true. After that, we added console, which has very similar functionality. There's a couple of places where it's a little bit newer, but it's still quite capable. And then the newest is Kubernetes native, which is very new and is not nearly as built out. But again, you're relying on your underlying platform infrastructure, so there's not as much that needs to happen in that space. Digging in a little bit deeper, briefly we touched on the request load balancing functionality that's baked into this stuff. We talked about random and round robin. The round robin provider actually uses the iDistributed cache infrastructure. So if you have a Redis server that's shared between whatever front-end instances you're using, you can make sure that it very fairly round robins even across multiple front-end instances, so that the back-end services get hit very, very, very fairly. Or you can take this load balancer infrastructure and do virtually anything with it. It doesn't have to be used just in HTTP. If you wanted to load balance between days of the week, you could use it to do that in your own applications as well. Some of these registries support high availability. We do as well. The discovery first strategy is something that's very commonly used in Java and Spring World. The idea here is that you can deploy your application to an environment and provide it just the address of the registry. And from that, your application can get a config server set up, and it'll go find the configuration that's relevant to that environment. And really all you're doing when you deploy is provide one piece of information, and then it can discover the rest. Additionally, Azure Spring Cloud is available, and it will be launching with .NET support with Steeltoe later this year. So where do you want to go next? There's all kinds of stuff. You can go read more in the service discovery page on steeltoe.io. There's getting started guides.
So I've always been a really big fan of service discovery. And even just looking at your demo, like it's really clear, like there's some really interesting benefits there. So for me as a .NET developer, it didn't look like there was a lot of configuration. Again, the tooling and the familiarity with my general workflow doesn't feel like it was disrupted at all, right? And then I have the ability now that I could start discovering services, and I'm not necessarily coupled to these services, right? So if I'm understanding correctly, I could change my configuration. I could just point to different registries, and I don't have to install, another client. I don't have to do another DI thing, right? All I have to do is just change configuration, and now these things would kind of just light up and work for me. Which for me, that's what I want, right? I want to focus on my code and have the infrastructure do what it's supposed to do, and have that confidence that it's just going to work, right? And so that's kind of how I feel about Steeltoe when I see you do really cool demos like these.
Absolutely. And then one of the other things that's cool about the Kubernetes world is you'll be able to deploy your app to Kubernetes, and if you want to start with the service discovery infrastructure that's provided out of the box, you can do that. And then if at some point it isn't meeting your needs and you need to discover services outside of your Kubernetes cluster, you can swap that out for Eureka or console and have instantly upgraded capability.
Great, man. Well, hey, thank you both for coming on. This is a really exciting episode. And I know we have some more that we're going to have recording in just a little bit. So thank you both, David, and also you, Tim. And thank you all for watching. This has been another episode of the On.NET Show. And we've had some folks from the Steeltoe team come on to show us how we could do service discovery in our .NET Core applications.